Hi, and welcome to this video on derivatives. So we have the quadratic polynomial 3x squared plus 3x plus 7, and we need to find the derivative of that polynomial at the number -3 using the definition of derivative, and then we need to use that derivative to find the equation of the tangent line to the parabola 3x squared plus 3x plus 7 at the point -3, 25. To work with this problem, we need to know the definition of derivative as a limit. So we have, let's see, find f prime of -3 using the definition of derivative. Now there are two definitions that coincide that are equivalent that we need to keep in mind to solve this problem, like part of this problem. One definition tells us that f prime of a, where a is a number, is the limit as h goes to 0 of f of a plus h minus f of a over h. That's one definition. Another definition that is equivalent tells us that f prime of a is the limit as x goes to a of f of x minus f of a over x minus a. Because we have here f prime of -3 is the limit as x goes to something of the expression something, we need to use this definition, the one in which we take the limit as x goes to a of f of x minus f of a over x minus a. So between the two definitions, we like this one more for this particular problem, just because we see that we need to use the limit as x goes to something of certain expression. Now, according to the definition we have right here, this definition, we take the limit as x goes to a of f of x minus f of a over x minus a. In our case, our f is 3x squared plus 3x plus 7, and our a is -3. Because we're interested in finding the derivative at the number -3, a is -3. So we can say that by definition, f prime of -3 is the limit as x approaches -3 of f of x minus f of -3 divided by x minus -3. So f prime of -3 is the limit as x approaches -3 of the expression that we have right here. Now we need to find that expression more explicitly. So let's find f of x minus f of -3 over x minus -3 more explicitly so that we write the answer right here. F of x is 3x squared plus 3x plus 7. Now f of -3 comes from making x equal to -3 in this equation of f. So we do 3 times -3 squared plus 3 times -3 plus 7. And then we divide the whole thing by x minus -3, that gives us x positive 3. X plus 3. So here we have 3x squared plus 3x plus 7 take away, and when we compute this number right here, we find 27 minus 9 plus 7, that's 25, and then divided by x plus 3. So back to what the problem we're trying to solve, f prime of -3 is the limit as x approaches -3 of this expression right here. And this expression, that is the same as what we wrote here, is this formula we see right here. So we write 3x squared plus 3x plus 7, take away 27 divided by x plus 3. That's the answer to this part of the question. Okay. Okay, so let's erase here. So far we have reviewed the definition of the derivative in terms of a limit as x approaches something, of something. So we have that, what we have completed so far. So f prime of -3 is the limit as x approaches -3 of this expression right here. Now, the next thing we need to work on is we need to find a limit, because we need to complete this part of the sentence. Oops. We need to complete the value of this limit is, and here we need to find a value. So next we're going to find the value of the limit. So the value of the limit is what comes next. We're finding the limit as x approaches -3 of 3x squared plus 3x plus 7 minus 25 divided by x plus 3. So let's find that limit. This limit is the limit as x approaches -3 of 3x squared plus 3x, and then 7 minus 25 gives us a -18, and then divided by x plus 3. And at this point, we can try to substitute x equals -3 into the equation we have right here. But when we do that, we find a 0/0. That will always happen when we try to use the definition of derivative. We will always get a 0/0. It makes sense. So we can't find that limit by direct substitution. But because we have a 0/0 when we make x equal to -3, that suggests that we can simplify the expression. So let's factor out the quadratic. Let's see how we can factor out the quadratic. We can write 3x squared plus 3x minus 18 in terms of x plus 3. See how that happens? Notice that we can factor out a 3 to get x squared plus x minus 6. And then we can find two numbers that multiplied in -6 and add up to +1. We get the numbers x plus the numbers 3 and -2. So we get that the quadratic x squared plus x minus 6 is x plus 3 times x minus 2. Now, then when we divide the quadratic 3x squared plus 3x minus 18 by x plus 3, we get this whole expression here divided by x plus 3. The x plus 3 goes away, and then we find 3 times x minus 2. Then what we're saying is that the limit of a function at -3 is the limit as x goes to -3 of 3 times x minus 2. And this limit can be found by direct substitution. We can make x equal to -3. And the answer is -15. So the limit is -15. Okay. Okay, so the value of the limit is -15. Let's move on to the second part of the question. They tell us, use this, that is the -15, to find the equation of the tangent line to the parabola, and the parabola is exactly the function we started with, at the point -3, 25. The equation of this tangent line can be written in the form y equals something. So let's find the equation of the parabola, of the tangent line to the parabola. Let me erase here to make room for the second part of this question. Now, the equation of the tangent line to the parabola at the point -3, 25 can be written as y equals mx plus b, where m is equal to the derivative of the function at the x value we see right here, -3. And we need this line to pass through the point -3, 25. By definition, that line looks like mx plus b, where m is the derivative of the function at -3, the x component of the point through which the line passes. We found that the derivative of the function at -3 is -15. That's based on the first part of this question. So we're saying that the slope of the line is -15. So we need the line to look like -15x plus b. And we need the line to pass through the point -3, 25. To find b, we substitute the point -3, 25. We have that 25 should be equal to -15 times -3 plus b. So we're saying that 25 is 45 plus b, or same thing, b is 25 minus 45, and 25 minus 45 is -20. So b is -20. And with that value of b, what we can say is that the line has equation -15x take away 20. So here we write -15x take away 20. Okay. So we have filled all blanks. To summarize what we did, we used the definition of the derivative to find the derivative of the function at -3, and then we used that derivative to find the equation of the line tangent to the function at the point that has x coordinate -3. Right, if you have questions about this problem, please write a comment or contact me, and I'll be happy to help you. Thank you for watching. Bye-bye.